So in the given problem, he has given two signals which are continuous signals and is asking the convolution value of those two signals. Okay, so first write these two signals in the form of discrete, because if you see physically the signal h of t graphically, it will be looking like a discrete signal, right? So first I'll write x of t is here and I'll write h of t is here. And also if you see the values, he has not given the values in equal intervals, because if you see h of t is given at an interval of 1 but x of t is given at an interval of 2. So you have to find out x of t at an interval of 2. So how do you find out the value at t equal to 1? So here the slope is, which is the slope? I can write x of t is equal to 1 by 2 into t, because the slope is 1 by 2. So at t equal to 1, substitute t equal to 1, this is 1 by 2 into 1. So this is at t equal to 1, it is 1 by 2. Similarly, at t equal to 3 also it will be 1 by 2, because it is a symmetrical wave. Okay, then after that, so you just write all the values in discrete signal. So this is at n equal to 0, and if you see here, this signal started at t equal to minus 1. So when I am writing n in terms of discrete, so h of n equal to 1, 0 and minus 1. It is started at minus 1. So this is the value at n equal to 0. Now I want to find out the convolution of these two signals. So when I want to find out the convolution of these two signals, I will put it in the form of a box. This is a box where I will write here x of n and I will write here h of n. So what are the x of n values? 0, 1 by 2, 1, 1 by 2 and 0, and h of n is 1, 0, minus 1. So 1 into, if you multiply all the values with 1, you will get the same values. And when you multiply 0, you will get all zeros. When you multiply with minus 1, the minus of values. So this is 0, this is minus 1 by 2, minus 1, minus 1 by 2, 0. So here y of n, so from what value it will start? This value starts with a value of minus 1 plus 0, because x of t is starting from 0 and h of t or h of n started with minus 1. So the starting value is minus 1. So how many values it will be there? You can see here, this is 1, 2, 3, 4, 5, 6 and 7. So this is 0 and 0 plus 1 by 2, 1 by 2, next is 1, then 0, then minus 1, then minus 1 by 2 and 0. So this value started with n equal to minus 1. So this is n equal to minus 1, this is a 0. Now I'll plot the signal. If I plot this signal, this is n equal to 0 point, because it started with minus 1, so I'll represent minus 1 as well. And this is 1, 2, 3, 4, 5. How many values? 0, 1, 2, 3, 4, 5. So 5 is enough. Now I am plotting y of t. So at n equal to minus 1, it is 0. At n equal to 0, it is 1 by 2. So I'll take this as a 1 by 2. So this is the point. And next, at n equal to 1, its value is 1. So this is a point 1. So this one. And at n equal to 2, it is 0 again. At n equal to 3, it is minus 1. At n equal to 4, it is minus 1 by 2. So this is minus 1 by 2 point. So this is here. and at n equal to 5 it is 0. I'll just join all these points. So how it looks like? It looks like this. What is asking? Is asking minus infinity to infinity y of t into t. So the integral is nothing but the average, the area under the signal y of t. So if you see here, with respect to point 2, this is symmetrical. So that means this area and this area same. So this is positive area, this is negative area. So the net area is 0. So that means its integral value from minus infinity to infinity is 0.